simple enough. I don't know. Dongle, presumably microphone. But Ani's coming here, right?
I believe so, yes, she is. She said she'll be here like around at...
Oh, there she is. She just got here.
So you and Luis will sort out...
Yeah, he's going to go first.
Gonna go first.
So your mic... And yeah. We will have to leave after... Yes, but that's what I'm saying. Okay, good. Yeah. Your mic... just because we're going to transfer it back.
Oh, I
maybe
see.
You just hold it in your hand, you switch that, it goes on. Okay?
Okay. Which one?
This little thingy. Okay? It should, but this is not attached.
This is not attached.
I don't see...
You know, oh my.
You need to attach... there's something needs to
Do
happen. Alright, actually, let me see. Hi, if there's anybody in that booth up there that can help our presenters with their laptops, I would appreciate it. Thanks.
So you're in the HDMI? And it didn't find you?
No.
Let's try letting it connect one more time. Now that it is up.
Yeah.
And if it doesn't find it, I'll go fit. Oh, yeah. There we have Amy.
Wait.
And we go fit a little.
Thank you. Oh, yeah.
Can you hear me? Is that good? Okay, awesome. This is great. Hi, everyone. My name is Luis. I'm a fourth-year American Studies major. I'm also a first-generation Latino college student from Southeast LA. And I took this course last spring with John De Niro, and I also took the Stats Connected course with your current professor, Adhikari. And I'm here to talk to you about a special program that folks at BIDS, and folks at D-Lab, passion students, and Professor Adhikari have been working on. But before we do that, I just want to do just a quick little thing with you all. I'll just do this together. I want you all to just close your eyes just for a bit, relax. No one's going to see your stuff. People are watching. So if we could just close our eyes for a bit, and I want you to do something. I want you to visualize, because what else do data scientists do? I want you to visualize a data scientist. Are we all doing that? I want you to visualize a data scientist. I want you to visualize them in front of a computer. I want you to visualize them giving a presentation like this. And now I want us to open up our eyes back up. And I just have one simple question for you all. Did the data scientist look anything? Did the data scientists resemble you in any way whatsoever? If not, then that's what I'm here for. I'm here to talk about the Data Scholars Program. It's been a program that's been in the works since the summer, like I said, with folks at BIDS, D-Lab, and Professor Adhikari. Because I know exactly how it's like to feel as if your identity makes you an outlier in the course. And it's not just, it hasn't just been Data 8, it's also been in numerous different courses in CS and statistics. And that's what we're here to, in a sense, address. So the Data Scholars' mission is to provide a encouraging, welcoming space for underrepresented and non-traditional students who are interested in data science, but for right now, who are just taking the DS8 course. We wish to make new mentors and femtors in the data science community by providing a specialized cohort of similar students from similar underrepresented backgrounds, because in a class like this, it could easily feel like as if you are the only one. Through specialized office hours and having a specialized study session where you could work with students similar to you, we hope to help address these gaps, because we believe that in data science, the student body has a direct effect on the types of data we're collecting, the types of data we are analyzing, the questions we're asking, and the questions that are being answered. And we hope to address this by providing a welcoming and safe space for you all to be your unapologetic selves. And so the link is right up there. It will be up for, say, about a week. And if you have any questions, I'll be here to answer them after class. And thank you very much for listening to me.
Yeah, please. Hi all. I would just like to point out how important this program is. It is modeled after successful programs on this campus in the biological sciences, in computer sciences, and so on. And it is very student-driven. Ruta, would you please show yourself? There's a past student who is helping design it and will be part of the tutoring team. There is another student who couldn't be here who is also part of the team. And so, you're all grown up now. And while we like to think we know what's best for you, you know what's best for you. And these students know what works for students and what doesn't. So please, they are putting in a great effort. Take advantage of the effort. And we'll all, especially the field, will be the better for it. Thanks. And now, as you are used to, connector instructors introducing their connectors. Thank you so much.
All right, can you guys hear me? I'm just going to kind of hold it up to my face like this. So my name is Chris Holgraff, and I'm just going to speak really quickly about a new connector course that we've put together for this semester. It's going to be covering the topic of cognitive neuroscience and the sort of many different ways that data science interacts with this field. So I'm just going to give a quick rundown, and if you're interested in it, I'm going to have some info at the very end, and you can get in touch with us and see about enrolling in the class. So first of all, we are 4 graduate students and postdocs in the neuroscience program here at UC Berkeley. We do work on a number of different fields, and we sort of have different kind of angles that we take on asking questions about the brain and using data to do so. But really quickly, I just wanted to note, why is it that we're all interested in neuroscience, and why maybe you should be interested in it as well? So to my knowledge, most of the people in this room have a brain. And that means that neuroscience is really interesting because it sort of has something to say about everybody. It's meaningful to everybody as long as you have a brain. Moreover, neuroscience data, or the data that we collect from brains, is really, really noisy and really, really complex. And that also makes it really interesting and really challenging. So if you are good at analyzing data in neuroscience, then there's a good chance that you're analyzing lots of other kinds of data as well. So even if you don't imagine a career as a brain scientist for yourself, I think that neuroscience has a lot to offer to people interested in just analyzing data more generally. So this is all a little bit abstract, and what I wanted to do is just show one example of what brain activity actually looks like. So what I'm showing here is a movie that somebody is watching, and underneath I'm showing you basically a flattened picture of the very surface of their brain. It's called your cortex. And when it's red, it means that there's brain activity in a particular part of your brain. When it's blue, it means that there's less activity. And as you can see, there's all kinds of stuff going on in this movie. There's visual things going on, different kinds of pictures that you're seeing. There's also different sorts of ideas that we are presenting. And really, what cognitive neuroscience is trying to do is relate all of that complex information that we're showing that person in the video and try to see how your brain is trying to parse that information and understand it and represent it. So the problem is that when you collect neuroscience data, it looks something like this. It's really noisy. It's kind of uninterpretable. And what we really want to do is get something like this, where we can see a clear part of the brain that's responding to a certain kind of stimulus. In this case, it's a visual stimulus, this little kind of checkerboard wedge thing in the bottom right. And so really what our class is going to be doing is trying to go from the very raw, sort of uncut data, cleaning it up, polishing it up, thinking about also different ways that we can design experiments to collect better data, taking that cleaned and processed data, extracting different kinds of features in the brain and different kinds of features in the world, and then using statistics and a little bit of machine learning to try and relate those things in the world to the patterns of brain activity that we see. We're going to be using data from a number of different recordings from human brains. One of them is called electrocorticography, which is a technique where you actually put recordings directly onto the surface of someone's brain. So you actually remove their skull before you put an electrode on their brain. And the other one is called fMRI, which is able to sort of measure brain activity across a wide region of your cortex with very fine spatial detail, which is really cool. So if any of this is interesting to you guys, check out our website and the CCN up there, or shoot any of us an email, and we're happy to chat with you about it. I don't think we're going to be able to stick around today after this class, but you may see us around, and we're happy to chat if you get in touch with us. So thanks.
Hi all, welcome back to One Pimentel bright and early on a Friday morning. Thank you for coming. I notice, and this is going to be standard, slightly more acreage among the seats on a Friday. This tends to happen. I would implore the people who come to class, would please, if you would move a little bit in. We should not have people sitting on the stairs, especially on a Friday. And because you are here on a Friday, I especially appreciate your presence. We will today be talking about a data type called tables. But before that, some nitty-gritty, the usual nitty-gritty. I want to talk about the waiting list. I have numerous emails, to all of which, unfortunately, I have an unhelpful answer, which is at the moment I do not know. So the emails say, I'm changing my mind about 61A, I'm joining this class, I'm number X on the waiting list, what is my chance of getting in? I actually don't know the answer to that, and partly that is because the last several days when I have looked at what I see as the enrollment, it hasn't changed at all, which I cannot believe. So I am going to inquire as to what I am seeing compared to the reality. If the reality is that it hasn't changed at all, then on the one hand, that's great news because, I love the fact that students aren't leaving. On the other hand, it's difficult for people trying to get in. Give me until early next week to get some response back from people who might have more up-to-date information. At the moment, what's happening with the waitlist is that it is processing automatically. And the constraint is getting into a lab. Now, if you are on the waiting list at this point, I think it's a bad idea to try to enroll into another lab because you have to drop the class and then you lose your position in the waiting list, and there's all kinds of unhappiness. So this is now the end of the second week. Yeah, the first week was kind of short. It's the end of the second week. We've got a long weekend. People are going to be thinking about their classes. It's hard to be patient, but that's what we all have to do. I'll be talking to people about extending the class, but I like my students to be able to attend class. This room holds 527 people. 527 is going to be an important number. Okay, so what I'd like to do today is, by the way, administrative questions, anybody? Yes, please. So that is a good question to which I don't know the answer. If a lab is open, and the lecture is waitlisted, I've got about 6 emails about this. I have sent the email to the right person. I will email all of these people the answer when I know it. What's happened is we have a cross-listed class. So we have Stat, CS, and Info, and the class has been split into 63 pieces. There are 3 lectures, and there are 3 each of 20 labs. And so there may be some, lack of consistency between, or sort of lack of coordination between information. I don't know, but that is one of the questions that's being asked. Thank you, and I'm looking for the answer. So what's happened is normally, in previous years, I used to be able to answer questions like this. We've moved to a new system. I do not understand it, so I'm trying. All right. You will recall, main business of last time was different types of data. Why are we studying different types of data? Because there are different types of data that we want to work with. And this table is one that you're familiar with. It's part of Minard's data on Napoleon's March. We saw last time floats, integers, and strings. We also saw arrays. Now, an array is a sequence that we can manipulate easily, and we are going to need to manipulate sequences because we have data on collections of individuals, and those data often come as sequences of one kind or another. Crucial property of an array, all the elements must be of the same type. And once we have an array, we can do arithmetic. So if we take an array, I take an array and I say the name of the array is my array. And I type in my array divided by 20. What type of object will I get back? An array. What will be the contents of that array? The old array with each element divided by 20. Yep. So that operation divided by 20 to an array does one by one a division by 20 for each element and then returns that array. And so you can do division by 20, you can do any kind of arithmetic operation, and it will work individually. If you have 2 arrays of the same size, we saw this last time, if I have the array 1, 2, 3, and I have the array 10, 10, 10, and I add these 2 arrays, so we're going to do this in our heads. 1, 2, 3, 10, 10, 10. I add these 2 arrays. What am I going to get? 11, 12, and 13. Yes? Because you're going to add element-wise. All right. 1, 2, 3, 10, 10, 10. I multiply the 2 arrays. What am I going to get? 1, 2, 3, 10, 10, 10. Multiply. What are you going to get? 10, 20, and 30. Right? Element-wise multiplication. Okay. So what we're going to do now is I'm going to go back and look at this table. And it is an object that is called a table. This is formally a class of objects in Python created in the data science library. Each of the columns has a label, and each column is an array. What I'd like you to do is take a look at this row right here. Second row, see it? Is that an array? Yes, no, or maybe. So let's try the maybes. No. Yes. Okay, that's a brave person, right? And I appreciate it. Thank you. He's got an opinion. He's not afraid to show his opinion. Thank you. Without you, my classes would be a dud. Okay. So, defining properties of arrays, an early, so I gave you 2 or 3, and it's hard to remember them all at once. But maybe somebody can remind me of what the first property was. All the elements have to be the same type, and that's where this row is falling down. I've got a float, I've got a string, it's not an array. Okay? All right, so rows are completely different types of objects, but the columns are going to be arrays. And why do we care about columns? Well, actually, we care about columns because we're going to do operations on columns. What I will do is I'll remind you of something you did in lab, and then we'll start working on tables. Do you remember in lab you used methods on strings to change lowercase to uppercase to lowercase, and so on? So a method basically is a function that operates on a particular kind of object. The typical way is you name your string, and then you have the name of the method, and maybe you have some arguments, and maybe you don't, and none of this makes sense until you actually see something. String methods operate on strings, duh. Okay, apple.lower. There's my string, apple. The method is called lower. To call the method, I have my string.method. It has no arguments. Lower, I think, as you will recall from lab, turns uppercase to lowercase. So it has that call has the value apple. Okay, so far? This is a memory jogger from what you've done from lab. I think you also, did you use replace? Yep. Okay, so I take apple, I replace the A. So now look, the string, that's the object. The method is replace. And a dot to say I'm using this method on this object with now these arguments. First argument is the string that you're trying to replace. The second argument is what you're replacing it by, and you from apple get Snapple. Okay? Again, memory joggers, and so of course now we have array methods that operate on arrays, and we will start with some array methods, get used to working with arrays, and then we'll go back to a table which is lots of arrays. And so, okay. So what I'd like you to look at, and please don't worry about it, is I have a whole bunch of import statements up there. I have matplotlib, this, that, because I might want to plot something. You're doing none of that. But you're not surprised now that at the top there are import statements. This warnings is because I had an old version and it was giving me warnings and I didn't want the warnings. I knew I was fine. So there's a bunch of stuff that you don't need. But at the top of most of your notebooks, there is a cell like that. Sometimes you can't see it, but it's there. So we said we'd do apple dot replace and fine. Okay, the data science library was written for this course, but to also help people who are learning Python learn data science. So it is now part of Python, and it is an evolving library. So what happens is last time it was written very fast and very well by David Culler, who was just here, and John De Niro, Sam Lau, who's one of our GSIs, and a bunch of people. And then as we started teaching, we kept developing it. We said, you know what, if we do it this way, it's hard for students to understand. If we did it the other way, they would be able to get it. So they changed it. And so it keeps changing. If you have this notebook system on your own computer, please be aware that you might have to update the library. This is why we don't ask you to download anything onto your own computer. You work on a browser, we just always give you the most recent version of the library. You don't have to worry about it. So unless you want to go out of your way to have things on your own computer, and some of you do, you really don't have to worry about this. This is just a line that will be there at the top of many of your notebooks. Okay, so this one you have seen before. This is our survivors data. Okay, make array creates an array from a bunch of numbers separated by commas. And what I'm going to do now is I'm going to do some array methods. So one of the things we'd love to do is just be able to extract any of these numbers. What I would like you to recall perhaps from lab, or if not, to hear for the first time, is that each of these has an index. So this is item number something. This is item number something else. This one here, which we think of as the first item, is item number 0. That's item number 0. That's item number 1, etc. And this is item number, I think, 7. And so we have survivors.item 0. Yep, that's the right answer. Survivors.item, let me try the last one. 7. And that looks good too. Okay? So item is an array method. You have the name of the array, survivors, dot, name of method, argument. Same way of calling a method as before. Some functions you have seen used in this way. Okay. If I run this thing, what do you expect as the answer? Just as a math answer, what do you expect? You expect 12 as the answer. All right, so let's take a look. All right, that's the what you expect. What I'd like to show you is another way of calling min. Maybe you've seen this before. Name of array. Min. Okay. This is a Python, part of Python syntax. You say that you give the parentheses that say that this thing is taking arguments. In fact, the argument that it is taking is the contents of this array that is named here. And if I run that, I get the same thing. Now, why would I do it that way when I can do it the first way? Well, sometimes it's just easier to read code if you say, well, that's the array, and then that was done to it, rather than trying to read lots of parentheses within parentheses within parentheses. So we can put together a bunch of stuff that we already know about working with arrays. Do you recall what this does? Last time's lecture, what does that do? Sorry? Somebody from back there. My thing is I can always hear what these people are saying. I can't hear you. What does that do? Yeah? Yes, exactly. It calculates the difference between each pair of consecutive entries. Right? So, and it returns, anybody remember what kind of object? And if you don't remember, well, we've got a computer, let's do it. So it returns an array consisting of all consecutive differences. Okay. What will happen if I run... When I say what will happen, let me just break that question into two parts. So if I run that code, what type of object will I get? Okay, can I see some hands from the back there? What type of object will I get? I have an array. I'm doing what kind of operation on it? It's an arithmetic operation. I'm doing arithmetic operation on an array. What am I going to get back? And if you don't answer, we'll just stay here forever. You'll get back an array, okay? And what will that array be now? What will that array consist of? Well, you can sing it out. Contents. Yeah, so what are the contents? What will I see? 5, yes, thank you. 5, 13, 27, etc. All right, excellent, thank you. Oh, I didn't. Yes, thank you. One day I'll learn how to type and talk at the same time. All right, okay, so now... one of the things we noticed last time is what is the biggest difference and So what this does is it takes all successive differences. You take absolute value of that, you get the differences without sign. You take the max of that array, and you get the biggest of the successive differences. Now, with an array of size 8, there is really no career opportunity in having a computer do this. But please note that precisely the same line of code would work if survivors were an array of size 3000. Yes? And when you have an array of size 3000, it's not so easy to see which one is the biggest one of the differences. So that's quite useful as a line of code that you can use later. And today what I'm going to be doing is I'm going to be doing a lot of... I've seen you. I'm going to be doing a lot of operations on small arrays so that you can see that you get the right answer. By the end of today, we should start working with quite a large array. Yes?
Is there any specific reason you don't put the whole expression inside max?
Is there a reason I don't put the whole expression inside max? So the reason I gave you up to now is that it's a little easier to read this way than putting max of the ab and so on. And we are going to be doing lots. We're going to apply one method, and then another method, and then another method, and then another method. So what this does, this method, this way of writing, takes things almost in sequence. You have an array, you apply the first method to it, then you apply the second method to that, and so on. It's a little easier to read. Give me a few moments and you will see. Okay, so we have array methods, and now I want to go back to tables. So a table is a sequence of named columns and also a sequence of rows. The columns describe one feature of the data set. You guys are all aware that these slides get posted, yeah? So if you are taking notes, do so because that helps you learn, but not because you feel you won't have the information. So you have a sequence of named columns, and each one describes a feature. It's also a sequence of rows where each row consists of different features for one of the entries. The columns are the arrays. And, well, what does all of this mean? So here's our old friend, the table. Okay. The entries are what you're making these measurements on. And those are locations on the map of Europe. All right, so you have Mirad's map. And each one of the entries is one of those spots. So, and each one of the entries corresponds to a row. And so there are 8 entries in all. There are 8 rows. The reason I am going slowly over this is I want you to be clear about when I use a word, what precisely does it mean? Because, other people say entries inside tables and so on. But for us, an entry is an individual on whom you are making measurements. And you have made 5 measurements on each individual. And the measurements are the longitude, the latitude, the name of the city, the direction, and the number of survivors. Okay? And so columns correspond to the 5 features, rows correspond to the 8 entries. Questions thus far? This is perhaps the most fundamental way of organizing data, which consists of several measurements on each of several individuals. You can see at a glance what is going on. So even as a method of visualization, this is a nice organization. Now you can imagine that if you have hundreds of entries and tens of features, then already it becomes hard to visualize. What we'll do is we will develop some methods of working with tables on this little one and then see the power of that as we have by going to a bigger table. Okay, so what we're going to do with tables is we're going to first create them and then realize that the way we are creating them is really long-winded. So then we're going to read them in from elsewhere, and then we're going to chop them, change them, and so we're just going to play around with tables for a little while. Okay. The table you meet first is one of the important ones. And here is how you create it. It's a table that has absolutely nothing in it. It is the empty table. That was the output. Isn't that fun? All right. Now, why create a table with nothing in it? Because there are table methods that allow you to add columns to tables. So I am now going to take this empty table and add a column to it. Here's how you add a column. Table dot name of method with column. Easy to remember. Empty table dot with column. And now, with column takes two arguments. First, I like to indent it a bit. It ought to do that by itself. The first argument is the name of the label of the column, which why don't we just do numbers? And the second argument is the array consisting of what's going to be in that column. And I've talked through a lot. What I'd like to do is just show you this. So I started with the empty table. That's this thing here. I took that table and created a new one. That is the old empty table with column called numbers, consisting of the arrays 1, 2, and 3. And I'm showing you that you can break the lines for ease of reading at these parens here. So I'm going to stop for a second, let you look at that code. You can do multiple columns. Take your empty table with columns, plural. Same deal. Okay, so right here, how about our first one? And now, comma, another column. Oh, let's just be wild and crazy here. Okay? Difference between with column and with columns is singular versus plural. You know, we could just have called the thing with columns, but then we got the grammar was bothering us when you were adding just one column. It was weird. Maybe we shouldn't be bothered by things like that, but we kind of are. And that's why you have two methods. Okay. What would have happened, do you think, if I had done letters make array A, B, C, D? Well, there would have been unhappiness because the columns are of different lengths. Shall we do it? We should do it. Unhappiness. So actually at the bottom, column length mismatch. Thank you. I wish the error messages went in the other direction, but they don't. Okay, much better. Now you can give this table a name. Did nothing happen? What happened? I created the table and assigned it to my table. You can extend my table. What do I want? So what happened was that we created a new table which has another column attached. The reason I'm showing you this is I want to show you my table. It's the same old my table. My table did not change. You created a new table, right? Okay, so we now know how to create tables, and by now you must be sitting there thinking, this is really boring. I'm not going to type in every entry of a table. Yes?
Is the order of the columns from left to right, is it according to your input?
The order of the tables, the order of the columns is according to the input. So we will see there are methods for switching the order around later if you want. Okay, so this is boring. We are not going to be typing in every single item of every single table, and so happily, the class of tables has a method. So this is like, you remember we had math.factorial, np.method, so table is something like that. So what we're going to do is a method called readTable, which reads in the data in our old friend, the Minard table. That happens to be in a CSV file. A CSV file is a comma-separated values file. If you don't know what that is, that's fine. It's just, lists of the entries separated by commas. So we have the file on our system, and I have it on my computer, and so I just do that. Table.readTable is the name of the method, and there is our table. That is a lot nicer than having to type that thing in. Now, there are tables on the web. There are tables, if you open up a URL, you get huge tables of data. You can just do read table of the URL, and out it will pop the table. So life becomes much easier. Okay? You don't have to type everything in. Okay, so now I want to give this thing a name. I'll just call it Minar. And let's make sure we can see it. If we do that, fine. So, size of the table. Number of columns. Num columns is a method. It gives me 5. Is that the right answer? Yes, it is. There are 5 columns. Number of rows. 8. I love it. The computer can count. We have 8 rows. It is very important to be able to get the size of your table, especially when the table is big and you can't see everything. Fine, great. We've got the size of our table. Labels. I tell you what. I said that the entries were points on a map. And so when I look at this column, a point on a map has a longitude. A point on a map has a latitude. A point on a map does not have a city. It's sort of odd. It's the city name. Right? And so I don't like that label. I want to change it. So what I'm going to do is I'm first going to show you a method called labels, which simply lists all the labels in case you can't read them all on the top. And could you not read them all on the top? Because the table is so big that it's going off your screen. So the method label shows you all of them, and then I can do minar.relabeled. I didn't like city. I wanted it to be called city name. And if I run that, I get a new table with a column name that I like. And I can name this table and work with it. All okay so far? Do you see that the methods all operate in the same way, name of table and then dot method, and that the names of the methods make sense relative to what you are trying to do? Okay. Important one, what we'd like to be able to do is extract data. Yes? You can relabel multiple columns, however, so why don't we do that? Okay, I can't type. How about that? Go for it? Yes? Does that answer your question? All right. Now, we are going to want to work with these columns. We're going to want to do arithmetic on the columns. We have to be able to extract a column. So, dot column extracts or accesses the array that is in a particular column. Notice that when I enter a column name, I am entering quotes because the column names are strings. If you don't enter quotes, bad things happen because it doesn't know what you're doing. Survivors. Much better. Okay, so this gives me the entries in the column called survivors. Now, once you have an array, then you should be able to tell me what is going to happen if I do this instead. Right. What number is going to be returned as the answer? 100,000. 0, 1, 2, 3. Check. Passes the check. Yes?
So even though you relabel the survivors to be a number alive, the table is still, the column is still survivors?
Yes, so good question. I relabeled the survivors column to number alive. This relabeling created a new table, right? It left Minard untouched. If I want to work with this one, I have to give it a new name and work with it. But my old table is untouched. We have tried as far as possible to avoid methods that transform your original table, because you can do something bad and then, there's weeping and gnashing of teeth. Okay. So you can access entries in your table, and you can surely take a look at what you think of this. So I am now going to extend this with a column that I will call percent surviving, and I am going to take, so with column is going to add a column that has a label percent surviving, and then the next argument has to be an array. You agree? Okay, I am going to do something. You agree that that's an array? Yeah, now that's a very boring array because it's already in the table, but I am going to look at the numbers relative to the starting point of 145,000 people, and if I run this, okay? So with column, augmented a column, and this was created by an arithmetic operation on this column right here. That is much more handy than having all kinds of separate arrays lying around in your notebook, all of which are related to each other. There is a section in your text that shows you how to actually format this so that it looks like a percent. That is, I'm going to leave that for another time. What I would like to do in my last couple of minutes is show what happens if we want to select entire columns. So now we can select. So what can we do? We can create a table. We can read it in from an existing file. We can extract any element that we want by first extracting the column and then the corresponding item from that column. We can relabel the columns. We can create a new column by doing arithmetic on existing columns. One of the things we might want to do is take a subset of columns, and so I'm just going to remind us of, we've done so much messing around with this table, I'm just going to remind us what this is. Supposing I want to get just the latitude and the longitude, I can do this. There, make sense? So .select creates a new table that contains just the columns that you want. Now, why don't we try the following? You don't have to enter the columns in the same order that they were before. This is a way for you to shuffle things around. Right? You might want to at some stage. Okay. You can also refer to columns by their indices, and for this I have to remind myself what the indices were. Okay, this is column 0, column 1, column 2, column 3, column 4. Okay, so you can do select columns 0 and 1. You'll get longitude and latitude, which is what you should get. You can change that to selecting. You can select the same thing in a different way. np.arange2 is what? It's an array because it gives you 0 and 1. Yep. Okay. Okay. Why am I doing the same thing over and over again? Because we have lots of different ways of doing the same thing. And for a small array, it doesn't really matter. All of them are about as easy as anything else. But imagine that you have an array with 300 columns, and you want to select some middle 50, right? Then in that case, it really helps to have a method where you can specify the middle 50 as an array that's generated, and then select those. You all agree? All right. And I will show you one last one. You can lose a column if you wish. Easy enough to work with tables? All right, so we've got a long weekend. I've got something for you to do. What I have for you to do is this. There is a section called tables, and it has pretty much exactly what I did in lecture. So I won't be uploading this notebook. It's already there in the book. There is an example that uses census data. You can just read that example. I'll come back to it on Wednesday. But you might have fun over the break just reading that example and seeing these methods used on a huge table.